Okay, here we go. Talking about Freon 12. Freon 12, which has the formula CCl2F2, is used as a refrigerant in air conditioners and as a propellant in aerosol cans. Space. Given a 5.56 milligram, watch out, sample of Freon 12, question 4 asks us to calculate the number of molecules of Freon 12 in the sample, while question number 5 asks us how many atoms of chlorine are in the sample. So let's tackle number 4 first. As we take a look there, we're going to start with our original 5.56 milligram sample. So 5.56 milligrams of CCl2F2. We're going to convert this first from milligrams to grams. So be careful, watch out, especially those mass values. You'll often be given things that are not in grams. You need to convert to grams first. So 1 gram is 1,000 milligrams. From there, we're going to go from grams to moles. 1 mole of CCl2F2 is equal to 120.91 grams. And if you're wondering, where do we get that 120.91 grams from? We went to the periodic table. We just took 1 carbon, 2 chlorines, and 2 fluorines and added those masses together to get the 120.91 grams. From there, we can convert to molecules. So moles, CCl2F2 to molecules, CCl2F2. 1 mole is going to be 6.02 times 10 to the 23 molecules. So if we bust out our calculator, we should notice that all of our units will cancel out except for molecules of CCl2F2. And when we put that on a calculator, we get 2.77 times 10 to the 19 molecules of CCl2F2. Again, as you try to estimate this and try and think about whether or not this answer makes sense, in 1 mole, we have 120.91 grams. And in 1 mole, we would have Avogadro's number of molecules. Well, we've got a lot less than 1 mole because we have only 0.00556 grams of CCl2F2, which is a lot less than 120.91 grams. So this answer, which is a lot less than Avogadro's number, only 10 to the 19, makes sense. Genius. Okay, question 5. This one's going to be set up the exact same way as question number 4. We're going to start with 5.56 milligrams of CCl2F2. And, you wouldn't have to do this if... I'm just going to write it out here. I know you math geniuses. 5.56 milligrams. Again, we need to convert from milligrams to grams. From grams, we'll go to moles. Again, this 120.91 coming from the periodic table, CCl2F2. I'm going to label here so I can make this a little more clear. CCl2F2. And here's what we're going to change. We're going to go from moles of CCl2F2 to moles of CCl2, no, just kidding, to moles of Cl. And so as you look at your equation for CCl2F2, for every one of these, there are 2 Cl's. Again, that just comes from the formula that's given to us in the problem. And then from there, we can now go from moles to atoms of Cl using Avogadro's number. Let me shrink this down. which equals 5.54 times 10 to the 19 atoms of Cl. Now, let's compare 5.54 and 2.77. 5.54 is twice as big as 2.77. And also, 5.54 times 10 to the 19 is twice as big as 2.77 times 10 to the 19, which makes sense because for every one of these, you have 2 Cl's. Boom.